Welcome to Super School.
You know what? Today is a great day for us to learn about matter because I see Addie doing something with liquid and solid, and I see you over there with something super cool that you created today out of Legos that's solid. So you know what? Today's a great day. Let's talk about solid, liquid, and gas. Sounds like a good plan?
Yes.
Okay,
Yeah.
well, everything is made of matter. Every single thing that you even see right here in front of you guys is made of matter. Everything that is made out of something either you see or something that is invisible. Solids, liquid, and gas, they all have mass. Let me hear you say that. Solid, liquid, and gas, they all have mass. Mass is the amount of material in an object. And they all have volume too because it's the space that they take up. So let's look at some things that are in front of you that might be made out of a solid. A solid can be big, a solid can be small. Some solids can be very, very tiny, like salt and like sand. Oh, we have some salt and we have some sand over there. And we have, that's even sugar. Sugar
Is this a solid?
a solid. Is that a solid?
Yeah, it's like a.
It takes up mass, it takes up
Yeah.
space, huh? So that is a solid right there. What else do you see on this table that would be a solid?
Beads.
Definitely a rock right there. Definitely even those beads right there. If you put a solid in another container, Miss Tiff, why don't you show us this? We take those beads that are a solid and we pour them into a different container. It doesn't conform to the shape of the container. See all those beads? They took their own shape, didn't they? They didn't change just because they went from one cup to another, did it? It stayed the same. So sometimes solids stay the same, but sometimes solids can change. Solids can bend and they can twist. Oh, look at that piece of clay we have on our table, Cohen. You see that clay, that pink clay? Can you twist it? Yes, you absolutely can twist it. Can you make it curvy? Can you make it straight? Yes, you can.
That's
So,
perfectly
but that's still a solid, huh? It's perfectly straight right there. Sometimes, like what you did with that airplane right there, you joined certain solids together to make a new shape. Hold up your Lego plane that you made. Very cool. Look at you, Mr. Cohen. But sometimes changes can't be undone. Now, Miss Tiffany, you have something in front of you that I want you to show us how this solid can be changed, but it can't be put back.
Can't be changed
It
back.
can't be changed back. So watch what Miss Tiffany's going to do. Only Miss Tiffany can do this because she is an adult. Now look what's happening right there as she changes. Look at what's happening to the paper.
Wait, we're burning something?
We are burning that paper right there. Now can that paper be put back? Look at that. Can it? It can't, can it? Do you see the ashes? That paper is gone forever right there. So the paper sometimes it cannot be put back.
Oh, it smells
But
amazing.
what about liquids?
It smells like Colorado.
Liquids can be thick like this stuff right here.
Thick,
Liquids
thick,
can be thick like glue.
Oh, what about this?
Is that a liquid? Open it up and let's see.
Ready? Are you ready, everybody?
Yep. Because you know what? When a liquid is poured into a container, what if you took that and you put it in that empty cup sitting right next to you? Will it take its shape? Let's watch. Oh, push it in there.
Might do a little farting.
So, would that be considered a liquid or would that be considered a solid?
I
A
don't know.
liquid.
That's kind of
it
a
can
little bit
change
different.
shape.
It can
It's a
change
little
shapes
both.
right there. It's a little bit of both. One thing that's super easy and liquidified is this thing right here called water. Water definitely is liquid. When it's poured in from one container to another, it takes the shape of that container. What happens if you spill water?
It doesn't
It
do
takes-
anything.
It takes the shape of the thing that you're pouring it.
That's right, of the spill right there. Now, did you know that we could take something that's solid and we could put it inside something that's liquid? And watch what happens to that solid. You see the little gas bubbles coming up? That's solid,
Can feel
liquid,
it.
and gas. And what's happening to the water as our solid is melting right there?
The poor little guy's melting away.
Changing
It's
colors.
melting away and it's changing colors, isn't it?
Oh, see you later, man.
It's kind of like water when you boil water and it forms bubbles of water vapor and they rise to the surface and they pop. Then the vapor rises into the air. Did you know that when you cool a liquid, it changes too? Do you know that I went to the store the other day and look what I bought for them to eat, Miss Tiff?
Oh.
I know, on a
Delicious.
beautiful, wonderful,
Oh, yeah.
sunny day. But when I first bought them at the store, they weren't in the freezer. They were just sitting on the shelf. So guess what they looked like? They were total,
Goo.
complete goo liquid.
Oh,
But then I
okay.
froze them.
Cook the shell.
Now, cut the top
Now
open
they're all
right
hard.
there. Let's see what happens. Now they're hard, huh? A popsicle starts off as liquid, and when you freeze it, it turns into something wonderful and
Tiny.
solid. Yes.
Delicious.
But it also could melt, can it? So many things can start off a solid, a liquid, and they can turn into a gas. Miss Tiffany, let's sing a song to help us remember about solids.
Solids? Okay.
While you're singing it, I'm gonna hold this rock to remind us that we're talking about something that is solid.
Okay, this is going to be sung to the same tune as If You're Happy and You Know It. I'm sure
We can
all
do
of
it.
you know that one, right?
Yes.
Okay, there you go.
Oh, a solid keeps its size and its shape. Yes, yes. Oh, a solid keeps its size and its shape. Yes, yes. Oh, a solid keeps its size. Oh, a solid keeps its size. Oh, a solid keeps its size and its shape. Yes, yes.
Now what about this one?
No,
Is this a solid? Nope. So let's sing about liquid.
Ready?
Oh,
A liquid keeps its size, not its shape. Yes, no. Oh, a liquid keeps its size, not its shape. Yes, no. A liquid keeps its size. A liquid keeps its size. A liquid keeps its size, not its shape. Yes, no.
Then we have gas. Good sound, Cohen. So let's sing about gas, which is carbon
That's gas.
dioxide bubbles that go into the air from our Coke.
Okay. Gas doesn't keep its size nor its shape. No, no. Gas doesn't keep its size nor its shape. No, no. Gas doesn't keep its size. Gas doesn't keep its size. Gas doesn't keep its size nor its shape. No, no.
Ready?
Oh. Whoa.
That balloon was full of gas, wasn't it? You know what? Let's go outside and let's go see what we have. set
Oh, a
up
little
out there.
harder. I'll bring my ring.
Bring your rain.
Hey, what up, everybody? Welcome to our next experiment. We're doing some soda stuff, and you need some nerds. And that's all you need. Now let Jessa take it from here, because I don't know what else to say. So go, Jessa.
Okay, what do you think you need? You need nerds. but
Balloons.
You need a balloon and what else?
Some bottles of
Some
Coca-Cola.
bottles of Coke. It doesn't matter if you're using Diet Coke or regular Coke or any type of Coke you might happen to have at your house. Now, Miss Tiffany, I want you to show us how to get this experiment set up.
All right.
You need a funnel, and if you don't have a funnel at your house, you can use a piece of paper that you just kind of roll up, because the whole object is you got to have a way of getting the nerds into the balloon. And the easiest thing to do is to use a funnel. So you're going to fill that balloon up with some nerds. You may have seen this experiment happen with Mentos and Coke, but we're doing it a little bit different here today. Now, Addie, why don't you start taking the lids off those Coke bottles over there? Cohen, take the lids off these Coke bottles over here. We have a whole bunch of balloons already filled up, and we're going to try experiment to create some carbon dioxide gas to blow up a balloon. You think we can do it?
I think
I think we can do it. Okay, first thing I want you to do is you're going to put the balloon over the lip of your Coke, but don't let the nerds fall in the Coke yet. Let your balloon hang off sideways. It's a little bit tricky, but you can do it. You just stretch it over the lip of the balloon. You got it? Okay, put it up here.
all of them?
Over all of them. Yep, we're going to try it all at the same time.
Stop.
No, don't put it in there yet.
Why?
cool. Imagine if we put like 10 whole boxes of one.
We're about to put a
Wonder
whole
what
bunch in
happened.
there. Oh, that's why, because it's going to talk to you already.
Ah!
All right, are you ready?
Yeah.
Okay, here we go. Stand your balloons up. Let the nerds fall in. And let's see what happens to our balloons.
Oh shoot.
Dude.
Ultra man! Gnarly man! Gnarly!
That is what you call carbon dioxide.
That's not an experiment, bro.
Explosion!
Man,
Look how
gnarly,
these
bro.
balloons blew up so fast because it's having a reaction with the Coke, the liquid on the inside, and it's creating carbon dioxide, which is a gas, and we are keeping the gas from escaping by putting a balloon on top of it, but our balloon is being filled up. Woo! Pretty cool. Y'all want to try it with a bigger bottle of Coke?
Maybe not. Come can go sit down.
Let's try it out and see what happens with a big bottle of Coke. All right, take those off.
Cohen already has his off. Okay.
Hey, and the trick is if you use Diet Coke, because Diet Coke has no sugar, then you won't be sticky afterwards. But if you use real Coke, we learned the other day that real Coke has a lot of sugar.
Did you see that? It made smoke.
Did you know what that smoke is called? That's carbon dioxide gas that's coming up right there.
Man, some gross
Pretty
stuff.
cool, huh? All right,
And they
Cohen,
put
go
this
ahead.
stuff in our drinks. What's the
Can you
lid?
believe it? So do you really think we should drink Coke? Probably not, huh?
But it tastes
All right.
fabulous.
It tastes fabulous, yep. All right, but it's full of sugar. Not this one.
Maybe I should start drinking Diet Coke.
It does have other stuff in it.
Okay, you ready?
Nope.
Nope,
Good.
come
Now
on.
one more.
Cohen,
Okay.
explode. Cohen's
Hang
thing.
on.
See, you have to get it over the entire
Yeah, we have to get it a little bit.
People, I know what you're talking about. You want to see an explosion. Why don't we give the people an explosion? We already did that. Give the people what they want. Are you ready? Cohen, you have to hold. No, Cohen, you have to hold. There we go. Give the people an explosion.
Oh, Cohen. You have scared Addie away.
All right, Maddie, go for it.
Go, Addie, go. You gotta untwist it a little bit. Oh. Go on. You can do it. You can. Oh!
That's what I call explosion.
Cross your arms and just really handicap yourself here.
The science go crazy.
Whatever I do, I'm still better.
Isn't that amazing though how the Coke all jumped up here into the balloon and now look at it, it's all pouring back out of it to give room for the carbon dioxide gas that's on the inside.
That was an explosion. We gave the people what they want.
Total explosion. Oh my
I don't even know what's
goodness.
happening.
Hello everybody, welcome to Sip School. This is take 2, experiment 2, episode question mark. Hello everybody, you are going to eat some root beer floats. Okay, let's go eat some root beer floats. Stay tuned. Let's do this, Jessica.
Cohen, you are clearly delirious. We're talking about solid, liquid, and gas. You want to have something to snack on that involves
Yeah.
all three of those?
Of course, I'm
Okay,
sorry.
Here we go. We're going to sing a song first. It goes like this. Solid, liquid, and gas. Three states of matter. They all have mass. Solid, liquid, and gas. They all have mass. Can you sing it? Here we go. Come on, Tiffany. Here we go. Let's go.
Oh gosh.
Solid, liquid, and gas. Three states of matter. They all have mass. Solid, liquid, and gas. They all have mass. All right, let's heat up some solid, liquid, and gas. Let's start off with some solid
Ice cream.
ice cream. Woo!
I love some good old solid ice cream. That was a
Haven't had ice
perfect
cream
scoop,
in, like,
Miss
forever.
Tiffany. I know. And
Ice
it's a
cream's been
great
gone
day
because of
outside, so
Corona.
One,
it's
because it's kind of cold outside.
Perfect.
Two, because
Yes.
we don't have ice cream in our fridge.
All right.
2, 3. I don't know.
What we do today, huh? So we're gonna
Straight
start
on.
off with our solid. Now, what do you know about ice cream? It starts off in a solid state, but then what's
And then
gonna
it
happen
melts
to
into
it?
liquid.
It does melt
It is
into
like a
liquid.
liquid.
But we're gonna actually add some liquid to it called root beer. Pretty good, pretty delicious,
Sounds
pretty
awesome.
amazing. Now listen to what happens when I open up this root beer. See if you can hear it. Did you hear it? You heard the gas escaping?
I heard
Alright.
the gas.
There's even more gas on the inside, but we're gonna start with liquid, and it's gonna react with your solid ice cream, and some more gas is gonna form.
He's some shades
You ready?
in this movie.
You see the gas? The gas? That's
Ooh,
the
it
bubbles. That's the bubbles. It's okay. That's why we have a towel.
I'm eating
Solid
bubbles.
Liquid and gas.
And this is impossible. I have no clue.
3 states of matter. They all have mass. That means they all take up space. Do your bubbles take up space? Yes, they do, because look at them on Addie's spoon right there. They are taking up space on her spoon. Solid
Moving
liquid and gas.
bubbles.
Oh, this is one of my favorite things.